In this video for Unit 1, we're going to look at Section 1.8, adding and subtracting whole numbers. So there are two things that you may not typically do in your class that I'd like you to focus on. Let's start with addition. So we really want them in this section, again, to get a strong understanding or begin to get their strong understanding of what the operations mean. And we typically do that through various contexts. So looking at these two examples, Glenn is at school 2 miles from his house. He then walks 3 miles to a store in the opposite direction of his house. How far is his house from the store? Okay, not a hard one. They'll all look at this. They know what 2 plus 3 is, hopefully. So what I want you to focus on is notice that this is one sort of context for addition where we start with a value 2 and then we're adding on a number 3. Okay, so you don't have to talk about this for an hour, but compare and contrast it to this problem. Sharon has 3 apples and 4 bananas. How many pieces of fruit did she have altogether? Well, you're taking the 3 and 4, that's 2 sets, and you're combining them into 1. So that's 2 typical ways that we can think of addition. There's many more. I'm happy to share a great article with you. I think it breaks down to like 20 different types of addition. No, I'm exaggerating, but it's at least 7. So talk about these 2 ideas and then use manipulatives to represent these 2 ideas. So here, adding whole numbers using base blocks, let's just look at a problem and how you might connect it to these 2 ideas. Okay, so here we have 8 plus 2. Again, I know not incredibly cognitively challenging. Okay, and this is more of a discrete model than maybe the first one, which is a continuous model. And we also do want, you don't necessarily have to tell them about the discrete and continuous, but you do want them to see multiple types. So this one might look like something like the apple and banana problem. You have 2 sets and you want to combine the 2 sets into 1. So if we have 8 and 2, they can do this by hand, but I like the way this site does this. I will lasso all 10 of them. And now we have 1 10 unit, which we can carry over to the tens place. Okay, let's make one a little bit more complicated. So here we have 29 and 82. Okay, so we can group together 10 of these, carry it over to the tens place, and now we want, there's more than 10 of the rods, so we can regroup that into 100. This is 8, 9, 10. And that regroups into a flat. So you could have them and carry to the hundreds place. And there's our result. So one thing you may want to do is have them do problems like this with the base blocks and write the results and then connect it to the algorithm and show them how the carrying worked. So a lot of them know how to do this algorithm, but they don't understand how it connects to place value or the reason why they're really doing it. Okay, so for another way we can represent this is, of course, a number line. There are double number lines that you can use expo markers on if you want to show them this way. And the idea of here, we don't think of regrouping as much, okay, because it's all on the number line, but we can go 3, and then we're adding on the 8 from the 3. That gives us a result of 11. Okay, so the base blocks are really showing us the regrouping and the algorithm, and then you can touch base on the number line continuous model as well. Sorry. There we go. Okay, now subtraction. There's 2 subtraction examples here. 2 types in context. Again, we usually start in context to help them understand and relate to real life. Okay, so we have comparison problems and takeaway problems. Okay, and students typically think of all subtraction as takeaway. They think those 2 words are synonymous, so it's important they understand comparison. So this is comparison. Isabel jogged 8 miles on Monday, 14 on Tuesday. How much more did she jog on Tuesday? So we're comparing the values 8 and 14. And there's a couple of ways to think about this in terms of a number line. So here's 0, here's 8, here's 14, and we want to find this difference. Okay, and the word difference gets a little bit tricky with subtraction, so we call the answer to a subtraction problem a difference. But if I asked you the difference between 8 and 14, you likely wouldn't say -6, you'd probably say 6. So the word difference seems to have an absolute value context in it. Okay, so when we look at these, we'll find that the difference is 6, and when we get to integers, we'll talk about direction a little bit more. Okay, so just comparing and contrasting this to, they could set this problem up as 14 minus 8, which they could think of as 14 take away 8. Start at 14, take away 8, and get to 6. Okay, so it's two different interpretations of subtraction, and they should be exposed to both. In terms of, and then notice this one is a takeaway. You have 23 marbles, you lose 9, so you're taking away the part 9 from the whole of 23. Okay. And then in terms of the base blocks, this is the NLVM website base block representation. I'm not a huge fan of this, so notice it has the red ones are the ones we're taking away. This looks a little bit like integer chips, which we'll do later, which I guess is okay. But the idea here is that we have blue and red ones need to cancel out, and your goal is to get rid of all of the red. So if you wanted to use a takeaway model for this, you'd start with 46 and say, hey, take away 38. So I can't move these, sorry. And then you'd have them take away these 30, they'd take away 6, they'd have to break up the 10 to have 8 to take away. Okay, if you want to use a model like this, or if you're using the website, our goal is to get all of the ones in the second number to cancel out. So notice when I overlap them, they cancel. Then here we're stuck. We have -2, which they might not be quite ready for, but some of them may understand it. Notice I borrowed from the tens column. It shows that in the algorithm here. And then when all of the reds are gone, what remains is your result, and it shows the answer. Okay, so that's the basic gist of addition and subtraction. So make sure to give them multiple contexts and to use both the takeaway method and the comparison method with the base blocks. I actually didn't do comparison method with base blocks. Okay, so with the comparison method, you may think, so what would I add on to this to get this? Okay, so I can't do it on this physical screen, but you could have them represent the 8 and then see what they would add to the 8 to get 17. Well, they'd add 2 singles, then they'd add 7 more, that would be a total of 11, and then you'd regroup into 10 and 1.